Problem 20, sometimes it goes to the fourth term.
Problem
We get
20.
something, but it doesn't have the exponent.
Yes, it's supposed to have a 10 on it.
Okay.
Yes, that was a misprint on my part, so yes, on number 20, the power on that thing is the 10. Since I left that off, that would be a key piece of information to know in order to do the problem. Yep. Can't really do it without it. All right, so you found something you need to review as we prepare for our exam. Thank you, Debbie. And then you have 7.5 homework. Did you already turn that one in? Sometimes I don't mark it off. Did you already turn that one in? No, I didn't. All right, get that one sent to you. Okay. Sam.
Duty number 17.
17. Okay. What are the potential answers to this question? 0, 1, or 2, right? No credit for guessing. I guess if it happens to be a multiple choice question, some of your exam is multiple choice, then of course, yes, go ahead and guess. But if it's a free response question, you gotta show some work. So the way that I approach the problems, always have, is by setting up the lost signs. It makes sense to me because I have this pair right here. Am I on the wrong problem?
What problem is this?
17A.
Oh.
So this is a law of signs problem. So I set up the law of signs and I'm gonna find angle B. And I'm gonna find angle B by inverse signing this fraction. You with me, people? So second sine 11 sine 47, close those parentheses, divided by 10. So this angle is 53.6. So what does that tell me? That tells me that I'm at least going to have a triangle. Because what happens if there are no triangles? You get an error message. I didn't get an error, I got an answer. So this is one possibility. If there is another possibility, this angle B could be the supplement. So 126.4. So I second signed, got 53. If there's another answer, it has to be the supplement of this one, so it would have to be 126. Is it possible to have an angle of 47 and an angle of 126 in the same triangle? Is that possible? Yes. So there should be two answers to that, two possible triangles for that. If this had been 136, let's say, then it wouldn't be possible, right? But since it was 126, it is possible. So both possible angle B's work, and there are two triangles. Sarah? 30. 8 CIS, 312. Find the cube roots. So we're going to raise this to the 1/3 power. And luckily we're answering in polar form. Since the problem is given in polar form, it'll come out that way, so we don't need to do any changing. Okay, this is de Moivre's theorem. How does de Moivre work? Drew?
Take the cube of that first number and
So you raise the radius to the power. So 8 to the 1/3 is 2. And then take the angle times the power. So in this case it's a division. So what is that, 104? Now, remember that if you are rooting, you're going to have multiple answers. There's not just one. How do we find the other ones? I mean, they're all going to have a radius of 2. They are all the same length or the same magnitude or the same radius. How do we find these other ones over here, Sam?
You add 120.
And how did you get 120?
Because you take 360 divided by 3.
Exactly. So in this case, we're adding 120, but we're only adding 120 because it's a cube root problem. There's 360 divided by 3. In another problem, we'll be adding something else depending on what the power is. So when I add 120, what do I get? 224. And then another 120 is 324.
344.
344. Okay. All right, who else? Question? Robert? 29. So the number right now is in complex form, or sometimes called standard form or Cartesian form. So I need to change that to polar form. This is polar form, so this is what I'm shooting for. So I need to find my radius, and I need to find my angle. So this is a no calculator problem. Luckily, these are all good numbers here, so this is going to be 4. I do the Pythagorean theorem, and this is going to be a 30 right here, looking at the sides of the triangle. So my radius is 4, and my argument, that's what we call that angle right there, that angle is 330. Now, it doesn't say to answer in degrees, so that's fine. It doesn't say, but if this would be a multiple choice question, this might also be an answer, right? Because you could have the angle in radians also. Okay. Who else found something that we need to review now? Like,
Can we do 13?
find angle between these two vectors. Okay, well, this requires you, well, first of all, let's look at our vectors. So our vectors, I'm going to go ahead and just write them in component form, so that would be 2, -3. Remember, I is the horizontal unit vector, and j is the vertical unit vector. So that's just 2, -3, and u is -1, 1. To find the angle between two vectors, you need to find their dot product. So the dot product is x times x plus y times y. So the dot product is -5. The dot product is also the magnitude of the first vector, which is root 13, 4 plus 9 square rooted, times the magnitude of the second vector, which is square root of 2, 1 plus 1, times the cosine of the angle between them. Both of those are definitions of the dot product. Since they are both the dot product, I can set them equal to each other. So -5 is this equals the square root of 26 times cosine theta, and cosine is -5 over root 26. So to find the angle, I will second cosine. -5 divided by the square root of 26. So theta, the angle between those two vectors is 168.69. Okay. What if we found the determinant of this? What's the determinant of this thing? 2 minus 3, so -1. Right? How do I find if I if I wanna find the angle of a triangle, anybody remember?
You just divide by two.
Okay, that would be the area. That would be the area, remember? So I was hoping maybe this would be a little faster, but it's not, 'cause I still need the magnitudes. So this is the best way to do it, right here, the way you did it. That's the best way. That would be, area would be faster, but I'm not doing area. All right, looking for a fast way, didn't work out. Okay, who else has a question? Brayden?
25.
Cafeteria shows movies, there's a 90% chance they'll show popcorn, they don't show movies. Okay, what's gonna be my strategy on this problem then?
Tree.
I think I'll draw a tree. So, the first branch is gonna be movies or not movies. And then I'm gonna have popcorn or not popcorn. Alright, so if I show movies, there's a 92% chance I have popcorn. If I don't show movies, there's a 41% chance. If they show movies 2/5 of the time, so I can either use 2/5, or since I've got decimals here, I'll use 0.4 as 2/5. Find the probability of popcorn. So I'm gonna multiply these two, I'm showing a movie and having popcorn, so 0.4 times 0.92. Or, I'm not showing a movie and having popcorn. So that would be the answer to the question. Tyler?
Let's do 24B.
24B. Alright. Okay, this one isn't too bad at all. Got a couple of different options. One option would be to change sine squared into what? What can I change sine squared into? Or the way
One minus.
1 minus cosine squared. So you can absolutely do that. I think what occurred to me as I was writing down the problem was, what if I split this apart? So instead of writing 4 of them, I have 3 of them and 1 of them. Because these two I can factor out of 3, and what happens when I factor out of 3?
Just one.
I get a 1. So this is just 1, so I have 3 plus cosine squared. But you could, right from the beginning, change this into 1 minus cosine squared and end up with the same thing. Robert?
Will we be given any equations?
Yeah, you'll be given a formula sheet, like everything I've provided you with before you will have. So, like the sum and difference identities and all that stuff, the sum and term formulas, yeah. 18. So given that cosine is negative 5/3 and it's somewhere between 0 and pi. find the
13.
tan-
5 over 13.
Oh, you said 13?
No, 18, and then it's 5 over 13.
Oh, yeah, 5/3 doesn't make sense. Find the tangent of 2 theta. When I had this written, why doesn't that make sense? Yeah, cosine has to be less than 1. All right, so the first thing I'll do is look at my handy dandy reference sheet and write down the formula I need to find the tangent of 2 theta. That's the formula you use to find the tangent of 2 theta. So obviously, what I need to know is what's the tangent of theta, because then I can just plug it into my formula and I'll be good to go. So, what do I know about my angle theta? I know its cosine is negative, and it's up here in one of these two quadrants. Well, since it's negative, doesn't it have to be over here? And the cosine is negative 5/13. So using the Pythagorean theorem, that side is 12. So now I know the tangent is negative 12/5. And I just plug it into my formula and work it out. So that's negative 24/5 over 1 minus 144/25. Don't cancel these negatives here, guys. They don't cancel. That one's getting squared out. You do this however you want. I'm gonna multiply it by 25. So I would get negative 120 over 25 minus 144. I got 120 over 119. And notice, that's doable without a calculator.
Why can't the triangle be in like a force, or because the zero to pi?
And it wouldn't be in 4, it could be in 3.
Yeah.
All right, who else? David?
3.
I hope you guys spend more time studying than you spent on this last night. All right, I need the parametric equations for the line through these 2 points. So, in order to write parametric equations, we need to, well, I shouldn't say we need to. The easiest thing, I think, is to write the vector representation of the line. So the vector representation of the line takes a point on the line plus a multiple of the direction vector of the line. So it doesn't matter, I can use negative 2, 1, or I can use 7, 3. It doesn't matter. I pick a point on the line. Those are the 2 points I know are on the line. Now, people always want to put that 1 point here and 1 point here. No, 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 no. The direction vector goes here. So what is the direction vector of this line? 9, 2. So the parametric equations are negative 2, x equals negative 2 plus 9t, and y equals 1 plus 2t. Those are the parametric equations.
Curves, do you mean like that we saw?
Yep, those are the classical curves. And be able to, if I write down an equation, be able to tell which curve that is. What is that, by the way? Basel sun. And it is not a cardioid because these 2 numbers don't match. So that would be a lima sun. Then?
Can you do 21?
Yep. And this is the last one I'm doing because you guys didn't spend time on this at home. So I'm just gonna let you work on it, figure stuff out on your own. So 21, the box holds 10 blue, 9 red. Given that you choose an odd number, what's the probability it is blue? All right, so what do you think, then, about a strategy here?
Would we do the probability where it's like the chance of an occurrence over the total?
Well, that's what all
Okay.
probabilities are.
Would it be the number?
I would set up a tree diagram. So I'm gonna pick blue or red, and then I'm gonna pick odd or even. So what's the probability that I reach into this box and get a blue card?
Would it be out of like 19?
So
or
10 19s. There's
yeah.
10 blue ones and 19 total, so red is 9 19s, right? Now, I'm in the blue pile. What's the probability I get an odd number in the blue pile? 1/2. What's the probability I get an odd number out of the red pile? 5 9s and 4 9s. So the question is, given that you choose an odd, what's the probability it's blue? So what's the probability of blue given odd? That's what you're looking at. What is the probability of blue given odd? So, what's our little formula for conditional probability? Probability of both over the probability of odd. Okay, so what's the probability of blue and odd? Wouldn't that be this right here? So what is that? 5 19ths? Blue times, or 10 19ths times 1/2. So this one's 5 19ths, all right. But now I need the total probability of being odd, which would be this one plus this one, which is that also 5 19ths? So that denominator will be, add those together, 10 19ths. So it looks like your probability is 1/2. Alright, so you got the rest of the period to work on it, figure stuff out.